Hi everyone, thanks for taking the time to watch this video. Today we're going to be talking about P1, which is our literal equation section. Our objective today is that we will be able to take an equation and rearrange by solving for another variable. Before we begin, let's first discuss what a literal equation is. A literal equation is just an equation, right? It has an equal sign with multiple variables. So it's going to have more than just one x in there that we are being asked to solve for. You can be asked to solve for any one of the variables in there, and we got to tell you which one since it's a literal equation. A common literal equation that you've seen many times is y is equal to mx plus b. We have, in this situation, 4 different variables that we might be asked to isolate or get alone, right? So that is a literal equation. We're going to look at some that are a little bit more complicated than that today, though. And then, of course, we have the definition of solving. To solve means to find a value or a set of values that make an equation true. Now, to solve a literal equation, we are going to use the exact same process that we've used before. And that process being isolating the variable that you're trying to get alone. Now, through this process, we are going to be adding, subtracting, multiplying, and dividing, and even sometimes factoring variables as well as numbers at the same time. So there's a lot going on here, but really what it comes down to is our basic algebra manipulation skills. So let's hop into something easy that you're probably pretty familiar with right now already. Here's our first equation. 12x minus 4y is equal to 20. And in parentheses over here, this is how we're going to indicate the variable that we want you to get alone. So if I wanted you to get y all by itself, the very first thing we'd want to do before we can sit there and divide off that negative 4 or anything like that is we're going to move the 12x over to the other side. And the way we're going to do it, since it's positive, is we're going to subtract it. Now, just like we've seen before, 12x take away 12x cancels out. And we're left with a negative 4y is equal to, now this is where we got to think a little bit. 20 take away 12x, those are not like terms, so that we're not left with 8x. Instead, we're going to be left with 20 minus 12x. We can only subtract like terms from one another. Since these are not like terms, 20 minus 12x is as good as we can get. Now, from there, we still need to get y by itself. And we see that there's a negative 4 that is obviously being multiplied by it. So to unhook it, we need to divide. And in fact, we're going to divide everything by a negative 4 at that point. These two negative 4's cancel off, and we're going to be left with y is equal to 20 divided by a negative 4 is a negative 5, and a negative 12x divided by a negative 4 would leave us with a positive 3x. Now, sometimes this will get rewritten as y is equal to 3x minus 5. That would be standard form of a polynomial. But I think either one of those answers is perfectly acceptable for where we're starting. Let's take a look at another problem. Moving across, we have 3x minus 2a is equal to 7a. Now, in this situation, we are trying to solve for x. So let's make sure we get the x variable alone. The first thing we want to do is move 2a over to the other side. This time, we need to add 2a to both sides since it was being subtracted in the original. Addition undoes subtraction. They're inverse operations. These two are going to cancel each other out. Now, 7a and 2a are like terms, so we can combine those to get 9a. And our 3x will drop down. Again, we are trying to get x by itself, so let's get rid of the 3 using division. And we're going to be left with x is equal to 3a. Now, I'm just going to get in the habit of it right now, trying to put a box around my answer. And the reason for this is because on your homework that you're going to be submitting, I'm looking for you to do the same thing. That's going to make me grading it go a little bit easier, and it's going to help your work stay a little bit more organized. So let's please start to get in that habit. I'm going to do the same thing over here already. Let's move on to another one. Let's start to amp up the difficulty a little bit here. Here's our next one. We have a is equal to a plus b plus c, all divided by 3. And we want to solve for c. So, since c is over on this side of our equation, and it's in the numerator of our fraction, the top, and it's all being divided by 3, let's try to get rid of that 3 first. So since everything is being divided by 3, we can undo division by multiplying, right? Multiplying and dividing undo one another. They're inverse operations. But since this is an equation, we have whatever we do to one side, we have to do it to the other side. Otherwise, we won't stay balanced. Now, 3 times a is, of course, 3a. Since our two 3's cancel out already, we're going to be left with a plus b plus c. And our job is still to get c alone. So we got to get rid of the b and the a. So I'm going to subtract a from both sides. And I'm also going to subtract b from both sides. When I do that, these two terms are going to cancel each other out. So we will be left with just having c all by itself. And on the other side, if I have 3a take away a, that would leave me with just 2a. We can even slide that 2a over if you like that better. And we still have to subtract b from that side as well, so we will have minus b. So we find that c is equal to 2a minus b. Some people do like, or some teachers I guess too, would also like you to actually write the variable that you're solving for on the left-hand side always. So either one of these two answers would be acceptable. As far as me, I really don't have a preference. I would take either one of those two as just the same. Let's take a look at another problem here. In this problem, we're trying to isolate n. We're trying to get n by itself. This is where this starts to get a little bit harder, but as long as we have some basic algebra skills, we can overcome that easily. Now, whenever you see something in the denominator that we're trying to solve for, it's easiest to kind of get rid of that fraction. And since everything over on this side is just being divided by n, if we multiplied by both sides by n, we would eliminate that fraction altogether. So n and n would cancel each other out, and we'd be left with just r minus c. On the other side, we have n times p, so we can rewrite that as np. Now, we still are trying to get n by itself, so let's divide off the p. And we can divide everything on the other side by p. So I would be left with n is equal to r over p minus c over p. Another way that this might look is actually, instead of dividing both terms by p, often we will see that they just divide that whole side by p. So another way that that step could have looked is if I would have had np is equal to r minus c, dividing by p, we would get n is equal to r minus c over p. These two answers are absolutely equivalent to one another, meaning they work the exact same way. They're just different representations. I would take either one myself. All right, let's keep going. We're getting to kind of the harder problems. These have all basically been problems that I would guess you've been pretty familiar with. I hope so, at least. You're definitely coming off a lot of time without math. So jumping back into it's never easy. But I do believe you probably have had some background with them. All right, in this problem, we're going to try to isolate x. I should stop and refresh for a second. I should have told you this at the beginning. If I'm going too fast for you or you're struggling to keep up and write everything down, don't be afraid to pause the video, ladies and gentlemen. Pause, rewind, watch it a second time, whatever you need to do to understand these topics. If you were in class, you'd be raising your hand, I'd be stopping, I'd be explaining stuff. We obviously don't have that as a luxury anymore, so please don't hesitate to stop and do that. In this problem, we're trying to get x all by itself. There's a lot going on here. We see we have an x over here, and we have x's over here. So we're going to at some point have to get those two together before we can get x alone. What I would suggest in this problem is to start by getting rid of our fraction. Fractions do not make our lives easier here. So we're going to multiply both sides by 6. Since this whole side is being divided by 6, multiplying by 6 will cancel it out. And we have to do the same to this side. And we're multiplying the whole side by 6. So 6 and 6 are going to cancel each other out. And we're going to be left with x over, or x minus 8a. And on the other side, 6 times 3a is 18a. And 6 times a negative 2x would be a minus 12x. Now, with that, we have like terms on both sides that we will be able to regroup. So what I'm going to do is I'm going to move my x's to the other side using inverse operations. And at the same time, I'm going to move my a's to the other side using inverse operations as well. My 8a's cancel each other out on this side, and my x's cancel each other out on this side. X plus 12x would give us 13x, and 18a plus 8a would give us 26a's. The last part of this problem is going to be just getting x alone, so I will divide by 13 and divide by 13, and we will have that x is equal to 2a. Great job. Let's look at another one. This one could definitely be the toughest one. There's so much going on in here that we need to think about as we go through it. Now, the first thing I see here is I definitely see I have some distributing that I could be doing. So let's distribute here to start. So I'm going to distribute the 3 to each of those two terms, and I'm going to distribute the b at the same time. I got to make this thing look simpler before I can really even see what I'm dealing with. The only thing I really know at this point is that I want to get x all by itself. So to do this, 3 times bx is going to be 3bx. 3 times a negative 2ab would give us a negative 6ab. Moving across, b times x is just bx, and b times a negative 7a would give us a minus 7ab. And then at the very end, we know that we are still adding 3ab. Now, the nice thing about this is at this point, we can start to see some like terms emerge. Like term, like term, like term. Anytime we have like terms, we can obviously put them on the same pile, which helps us solve an equation. So what I think I'm going to do is I'm going to try to regroup all my AB terms on this side, and I'm going to move all my BX terms on this side. If you wanted to do that the other way around, that's absolutely okay too. Before I do that, if I notice that I have these two same things, let's put those on the same pile while we're here. So I would be left with BX, that part won't change. If I have negative 7AB and I add 3AB, that would leave me with a minus 4AB. And on the other side, these two are not like terms, so I can't put them on the same pile yet. Now, from there, I'm going to move my bx over to the other side. So I'm going to subtract bx from both sides. And to move the 6ab or negative 6ab to the other side, I need to add it to both sides. These two cancel out and cancel out, meaning I am left with just 3bx take away 1bx would just be 2bx. And on the other side, if I have a negative 4ab and I add 6ab, I would just have 2ab. Now we're getting very close to having this thing solved. If I want to get x all by itself, I need to get rid of this 2b that's in front of it. So I'm going to divide off 2b since they're all being multiplied together. These two pieces cancel each other off, so I'm just left with x. And on the other side, the 2 and the b actually cancel each other off as well. And I'm just left with a. So we just did this entire problem that started out admittedly very hard looking, and we find out that x is really just equal to a. This is why actually we have these operations with literal equations, because we can have a mathematical statement that looks very complicated, and we could plug numbers in there to try to figure out what we are getting for values. And what we find at the end of the day is that if we actually do some simplifying ahead of time, that really it's a lot simpler than we believed it was. We have two more problems to look at. These two, I believe, are going to talk about how we use factoring in this process, and then we'll get you going on your assignment for the day. So in this problem, we are trying to solve for p, and what you might notice about p is that we're seeing it in two different places over here. We see it right here, and we see it in this term over here. Now, unfortunately, we can't just put these two pieces or these two terms on the same pile. We can't combine them. And the reason for that is because they are not like terms. So what we need to do instead is we need to find a way to isolate the p. And the way we do that is actually by factoring. So to factor this, we want to pull p out of each of these two terms, right? Factoring and distributing undo one another. They're opposite operations. So if I pull the p out, I would be left with 1 plus 1 RT. And we know, of course, that this 1 doesn't need to be there. Now, just thinking that through, right, just to show that we didn't change the problem, had I distributed this back out, I would be left with what I started with. Right? That's how we know we factored something right, is that if I were to actually distribute it out, we'd be at the same point. We're not changing the problem, we're just making it look different right now. On the other side, we're still going to be left with A. Now, we still want to get P alone, and what factoring did is factoring made P hooked onto there by multiplication, so now we can unhook it using division. Since I want to get rid of this 1 plus RT, that's what we're going to divide by. Right? And that's a quantity, so we're going to divide that whole other side by that same thing. And what that will do is that will leave me with just P over here. And on the other side, I'm going to have A over 1 plus RT as my final answer. Great job. Here's another one where factoring is going to play a role. So in this problem, we are looking to solve for x. So we are going to start that problem by first distributing. When I do that, I will have cx minus d is equal to ax minus ay. Now, let's get my x's on the same side at this point. So I'm going to move all my x's. I'm going to make this my x side. That's where I'm going to try to get all my x's. In order to do that, I'm going to subtract ax from this side and ax from this side. I want to move d over to the other side too because I'm trying to just make that my x side, so I'm going to add d to both sides as well. My ax's are going to cancel out here, and my d's are going to cancel out here. On this side, we're going to have cx minus ax. Those two are, again, not like terms. They both have an x, yes, but we can't combine them together because we don't know what c and what a are. And on the other side, I'm going to have a minus ay plus d. Now, whenever we have two terms that both have the variable that we are trying to solve for, which is x, and we can't combine them together, then our only option that we are left with is actually to factor. So we want to pull x out of each of those two terms, meaning we'd be left with just c minus a. Right? And you can check, if I were to distribute that back out, I would end up at the same spot. On the other side, it's going to be unchanged. And the last part of this now is that now that x is hooked onto that quantity, c minus a, by multiplication, we can unhook it by dividing. And when we do that, this and this will cancel off, and we will be left with x is equal to a negative ay plus d over c minus a. One thing to note is that these two a's here cannot cancel at this particular time. And the reason for that is because of the fact our final expression here has a plus and a minus. Those two start to cause trouble in terms of in terms of just canceling those pieces out. So our final answer here would be this. Moving on, you're going to go and complete worksheet P1, literal equations. You should be able to find that in the folder. Thank you guys for watching. If you have any questions, please be sure to email me and let me know. Happy to help. Have a great day.